Welcome to the Video Professor's Computer Learning Series on CD-ROM. This is the same great lesson that is found on our videotapes. This CD lesson window will always play on top of any application, so you can follow along step by step to learn the program. We have packed this CD with information, and sometimes move at a pace that is faster than you'll be able to follow along with. To help you with this, we have designed the CD to work just like a VCR. You can pause, rewind, or fast forward the CD to learn each part just by clicking the appropriate buttons. From the Table of Contents menu, you can select or review any part of this lesson instantly. For your convenience, a Video Professor icon has been added to your desktop. To view this or future lessons, simply put the CD in your drive and click on this icon to start that lesson. Now, to get started, simply click on the menu item you want to learn. For best results, we suggest you start at the first item and work your way through to the end. Welcome to my third tape on MS-DOS, the most widely used operating system for personal computers. This lesson covers 6.0 and 6.2 versions of this disk operating system. Because this is an advanced lesson, I will assume that you have practical knowledge of the DOS subjects covered in my first two tapes, Getting Started with Your Personal Computer and DOS 6.0, 6.2 Level 2. You should have working knowledge of the copy, delete, undelete, DOS key, and format commands. You should also understand basic file management, such as making a subdirectory and how to change directories. If any of these terms are confusing to you, you should see my first two tapes. In this lesson, we will look at the two key files that control the DOS environment, the AutoExec.bat and the Fcbs files. The commands in these two files will vary from one computer to the next, but we can look at the most common command options and understand how they work. We will also explore utility programs included with DOS. These programs can be used to optimize the performance of your computer and perform routine maintenance tasks. Mem Maker helps set the best memory allocations for a given system configuration. ScanDisk and Defrag will clean up and improve performance of hard disk storage. Backup is an essential utility to protect against lost data. Before starting this lesson, you should have a safe backup copy of your configuration files. If you have your emergency boot disk from the previous lesson, you can use that. If not, you'll need an empty formatted disk on hand so you can make a backup disk that will include your current AutoExec.bat and Fcbs files. To effectively follow this lesson, you need DOS 6.0 or higher running on your system. The commands seen in this lesson are the product of DOS 6.2. Although you may see a slight difference in the way 6.0 and 6.2 display the same command, the command works essentially the same in either version. Before we begin exploring the configuration files and the utility programs, everyone should have their computers on and have the DOS prompt on screen. If your system opens to Windows, DOS shell, or some other program, exit out of it to the DOS prompt at this time. While your computer is going through its power-on routines, let me introduce Suzanne, my student helper for this lesson. Just follow along with her and you'll learn these advanced aspects of DOS in no time. Occasionally, Suzanne will demonstrate a command that you might choose not to use. If so, just sit back and watch. We'll let you know when to follow along with Suzanne and when you can just watch. Okay, is your computer started up now? When the DOS prompt appears on your screen, it will probably show the C drive. This is why the DOS prompt is often called the C prompt. The two terms mean the same thing. Viewers, if your hard drive has been partitioned, you should be working in the drive that holds your DOS subdirectory and the configuration files. It will probably be the C drive. To be sure you are in the root directory, type CD / and press enter. We'll be doing a lot of copy commands, Suzanne, so I think we should be sure DOS key is loaded to simplify the typing process. Actually, our AutoExec.bat file already loaded DOS key, but we can't be sure everyone had that line in their file. Suzanne typed DOSKEY and press the enter key. The message DOS key installed will appear if DOS key wasn't already installed. No message appears on Suzanne's screen because her AutoExec.bat file already loaded DOS key for us. Of course, you recall from our earlier lesson that DOS key remembers all the commands you have typed at the DOS prompt, so you can recall them with a single keystroke and edit them for quick changes. Now that we are all at the same place, let's create an emergency backup disk that will contain your current working versions of the AutoExec.bat and Fcbs files. It's a good idea to make this backup a bootable disk, so you can use it to start the computer even if something has gone wrong with your hard drive. If you want to check which version of DOS is currently on your system, type VER and press Enter. Suzanne, what are we using today?
It says we have MS-DOS version 6.2, Professor.
Thank you, Suzanne. Now put your floppy disk in drive A. Type format, space, A colon, a space, and then /S. The S switch makes a system disk with the necessary DOS command files to start up or boot up the computer. That's why we call it a boot disk. Of course, you don't need those system files on all your disks, just the ones you might need to use for an emergency start. If you are reusing your disk from an earlier DOS lesson or have upgraded from 6.0 to 6.2, you should reformat that disk with the system switch in order to update the DOS command files and to erase the older files on the disk. Now press your Enter key. Then again at the next command prompt. It will take a few seconds to format the diskette. When DOS finishes formatting, it will ask you if you want a volume label for the diskette. We don't, so press the Enter key to skip this procedure. The DOS system files plus command.com take up about 200K of disk space. Now press your N key to answer no to formatting another diskette. You won't see all these files listed in the directory, however, because they are hidden files. Only command.com will be visible in the directory. Command.com file is the DOS command processor. In a way, it is the boss of DOS. It is the first DOS command loaded into memory when your computer is turned on. From there, it manages the various DOS jobs by calling other files as they are needed into memory. Now that we have formatted our diskette, we need to copy our config.sys and autoexec.bat files onto the floppy disk. Both those files should be in the root directory on your C drive. Let's check. Suzanne, type dir/w/p and press the Enter key. Remember that you must press the Enter key after each command in order to send the message to DOS. There are the files. Neither one is very large, but size is no indicator of importance here. You may need to press your spacebar a number of times to get to the end of this directory list. Just keep pressing it until the DOS prompt comes back into view at the bottom of the screen. Now type the word copy, followed by a space, then the file name autoexec.bat, follow that with a space, and the letter A, followed by a colon. When the typing is correct, press the Enter key. Good! Now press the up arrow to recall the copy command to the prompt line. Now backspace over the drive destination and the file name autoexec.bat. With that done, type in config.sys, a space, an A followed by a colon. That's it. When the typing is correct, press the Enter key to copy the second file to your backup disk. To create a truly useful emergency startup disk, there are some other files you should copy. Your configuration files might ask for these command files, or they might be needed for other emergency recovery procedures. These additional files should be found in your DOS directory, Suzanne, so type cd-DOS to change directories. Now type dir/w/p to get another directory listing here so we can see the DOS command files. We don't need all of these for the backup disk, of course, but we will copy a dozen of them to your recovery disk. The screen shows the additional files to copy to your recovery disk. There are 6 COM or communication files to copy: format, SYS, DOS key, help, edit, and unformat. We'll also copy 2 help files, help.hlp and edit.hlp. These files hold the help screen information. And there are 6 exe or execution files to copy: EMM386, check disk, scan disk, undelete, QBasic, and smart drive. The final file is high-mem.sys. If you have a double density disk rather than high density, you will not have enough space for all these files. If you run out of room, omit copying the QBasic and help files because they can take up a lot of disk space. Use the DOS key to call up the same copy command for each file name. Just press the up arrow key until you find the copy command, then edit the command line to copy the new file to the recovery disk. Pause the tape if you need to while you copy these files onto your recovery disk. If you get a file not found message for any one of these, double check your copy command for a spelling error. If the file still does not copy, it may be missing from your DOS directory. Make a note of the file name so you can copy it from the DOS installation disk to your system and to your backup disk. With a bootable disk and these additional utilities, plus your working AutoExecBat and ConfigSys files, you have a perfect safety net to restore a working set of startup instructions to your computer. If your hard drive fails, you can put in this emergency boot disk to start the computer, and then use some of the utilities to diagnose and possibly correct whatever the hard drive problem might be. We'll look at the recovery utilities later in this lesson after we've reviewed the configuration files. Suzanne, type in dir, a space, an A, and a colon. Then press your Enter key so we can see if all the files copied to our emergency diskette. There they are. You should have 18 files on your diskette. Label your emergency boot disk to show that it has the current copies of your AutoExecBat and ConfigSys files, and also some important DOS utilities. You should mark the date on your label and also note the DOS version. Then put the disk in a safe place where you can find it if you need it. There, you have an emergency backup disk, Suzanne. I think we're ready to take a look at those mysterious AutoExecBat and ConfigSys files. Perhaps a good way to start thinking about the DOS configuration files would be to look at the startup process in slow motion. DOS allows you to start your machine and either skip the configuration files completely using the F5 key or step through each command separately by using the F8 key. Let's use the F8 method. Viewers, I'm sure your configuration files will be at least slightly different than ours, so please just watch as Suzanne reboots and steps through the files. Suzanne, release the disk from the floppy drive and restart your computer. And press the F8 key when you see Starting MS-DOS displayed on the screen. Now the screen prompt tells us that MS-DOS will ask for confirmation for each command. Suzanne, just answer yes each time by pressing the Y or Enter key. These are the commands in our ConfigSys file which will load before the AutoExecBat file. We'll explain the commands in detail in just a few moments. For now, let me just say that the ConfigSys commands load in RAM memory, the default settings and device drivers that are needed for our system. Next comes a series of commands in the AutoExecBat file. This is a special batch file that DOS looks for each time it starts. You can put just about any kind of DOS command in the AutoExecBat file, and it will run automatically each time the system starts up. After answering yes to some of these commands, you may see confirmation messages telling us that a particular utility program has been loaded.
Professor, some of these commands look a little intimidating.
At first, many DOS commands do look pretty computery. However, as you start looking at the purpose of each command, the language DOS uses to describe that action will make more sense. After we go through this lesson together, you should be able to decide which commands you might change. When doing so, keep in mind how your machine is set up, which programs you need to run, and how you like to work with a computer. Remember, you have your backup disk as a safety net, so you can always restore the working version of your configuration files from disk if changes to the commands do not work as you like. Suzanne, the last command in your AutoExecBat file opens Windows. We don't want to open that program, so press your N key to bypass this command. Suzanne, we just looked at the commands from the ConfigSys and AutoExecBat files as they loaded step by step. Now let's investigate each file a little more closely. The first command that we saw during the step-through sequence was in the ConfigSys file, so that's the first one we need to understand. The configuration commands in this file load default settings and reserve memory for various computing tasks. ConfigSys also loads device drivers needed by various software programs on your system. When DOS was installed on your system for the first time, it created a very simple version of this file. As you upgrade your version of DOS or add other software to your system, the ConfigSys file is modified by DOS to accommodate the new programs or upgrades. If you use Mem Maker to optimize memory, it also modifies the ConfigSys file. Most of these changes take place without any intervention on your part, aside from answering yes to a prompt during an installation process. To really understand the configuration files, we need to understand some things about computer memory. Everyone type MEM at your DOS prompt and press Enter. This command lists the types of memory on your computer and shows how much is being used. Viewers, your display will be different from ours, but you can follow along with a description of types of memory and begin to see how your computer is using its resources. Your computer may have as many as 5 types of RAM memory. Remember that RAM is random access memory, which holds information only so long as the system has power. Information moves between RAM and the CPU very fast, so part of a computer's speed depends on how much memory is available and how quickly the bits of data can race between the two places. The 5 types of RAM memory are conventional, extended, high memory area or HMA, upper or reserved memory blocks, UMBs, and expanded memory. The different types of memory reflect the growth of DOS and of computing power over the years rather than any significant physical differences in memory chips. Conventional memory is found in every computer. It is the first 640 kilobytes of memory space available to us. Remember that a kilobyte is 1,000 bytes, and a byte is about the same as 1 character. Any program that is up and running on your system must use some amount of conventional memory to do its operations, even if that program is designed to use extended or expanded memory. Our system has 640K of conventional memory. Right now, 37K is being used, and 603K is free. The area of memory above the conventional 640K and up to 1 meg is the upper memory area. This 384K area is mostly used by DOS to carry out its commands. On our 6.2 screen display, this area is represented by the reserved line. The total amount available to us is the 384K. In many situations, every bit of this space will be used by DOS to allow your CPU to communicate with your system hardware. However, we can allocate some of this area to other programs. The second line in Suzanne's config.sys file is a device driver called EMM386EXE. This device driver creates upper memory blocks, UMBs, within the reserved upper memory area. Memory within the upper memory blocks area can be used by programs other than DOS. On our system, 155K of upper memory is available, 28K is being used, and we have 127K free. A little further down on this display, we see total under 1 megabyte memory is 795K, which is the sum of the conventional and upper memory available for us by programs other than DOS. Just under reserved, we have a line giving us the status of our extended memory. Extended memory is, in a sense, a separate pool of memory to be used by programs other than DOS. It can be found in computers that have an 8286 or higher CPU chip. Extended memory is memory above 1 megabyte of RAM memory on your computer's motherboard. Today's PCs may have 4, 8, 16, or more megs of total memory. Most of that memory above 1 meg will be extended. Our system has over 15 megabytes of extended memory, which is abbreviated XMS. Currently, 1.2 megs of extended memory are being used, and around 14 megs of memory are free to use. Earlier versions of DOS didn't really know about any memory space above the original 640K limit. However, DOS 5 and higher versions include a device driver called Mem that allows DOS and other programs to use that additional memory space. Within extended memory, we can have another memory area. The high memory area, or HMA, is the first 64K section of extended memory that gets reserved by Mem to hold part of the DOS commands that would otherwise take space down in the conventional memory area. This can speed up the operation of programs that need to use conventional memory. The message at the bottom of this screen tells us that Mem has indeed loaded MS-DOS into the high memory area of our system. We can also have another source of memory at our disposal. Expanded memory is simply additional memory on an added memory board. The other types of memory we've talked about are located on the motherboard, but you can also add an expansion card for even more memory. When this happens, another device driver must be loaded in the config.sys file so DOS can find this extra memory. Some MS-DOS based applications can use this additional memory. Lotus 123 is one example. This type of memory is fading from the computer world because CPU chips are getting more and more powerful and can address more memory directly than this type of add-on memory. If you have an 8386 or higher chip, you can make extended memory look like expanded memory to the programs that require it by loading the EMM386.exe device driver in the Configsys file. The sum of all these types of memory on our system is 16,384K, of which 1,706K is being used, and 14,678K is free. Suzanne doesn't have any expanded memory on her system. Viewers, remember that your numbers will be different from ours, because our system may have more or less memory to start with. And also because more or less memory may be being used right now, depending on which instructions were given in your Configsys and AutoExecBat files. Suzanne, now that we know something about memory, let's look at the Configsys file and see how it goes about the task of managing the demands on our memory. Suzanne, the type command will list out the contents of a file on our computer screen. So let's use that to look at our Configsys file. Everyone, make sure you are at the C prompt, then type the word type, followed by a space, then config.sys, then press your enter key. We can now see the entire Configsys on screen. Everyone's file will vary in commands and number of command lines, so let's look at Suzanne's. It should give us a good overview of the basic structure of a Configsys file. The commands found in the Configsys usually load device drivers, set default settings, and reserve memory locations. If you look at the whole Configsys file, one thing you will notice is that every line has an equal sign in it. That gives us a hint about the general form of these commands. The first part of the command names some device or environment feature, and the second part tells how it's supposed to be set for this system. Device driver commands are easily recognizable because they include the word device in the command. The form of the command is device equals file name, with path including the full drive and directory address. Switches may be available for some devices and will be described in the documentation for that specific driver. Suzanne, the first line loads the HiMemSys device driver. As we can see here, the HiMem file is located on our C drive in the DOS subdirectory. The HiMemSys device driver manages extended memory, making it available to programs and guaranteeing that no two programs use the same portion of extended memory. The next line loads the EMM386EXE driver. The EMS stands for expanded memory. The no EMS simply tells the system that we don't want any expanded, that's EMS, memory. This device driver allows DOS and certain TSR programs access to the upper memory area.
Professor, does it matter which lines come first in the Configsys file?
Indeed it does. For all this memory allocation and management to work properly, the HiMemSys driver must be loaded before anything else. DOS won't be able to use EMM386EXE unless it already has loaded HiMemSys. The DOS equals hi command is not a device driver like the previous two commands, but it affects memory allocation. It loads portions of DOS into the high memory area. The UMB portion of the command activates upper memory blocks so they can hold device drivers. In the device hi command we see a little further down Suzanne's Configsys file is a variation on the device command. It loads device drivers into upper memory that normally wouldn't load in that memory area. However, before you can use device hi, you must have loaded HiMemSys and EMM386. You need at least 350K of free extended memory to use this command. If device hi cannot find sufficient memory to load a device driver into upper memory, it will place the driver into low memory. The main reason for loading these device drivers into upper memory is to free up conventional memory for applications such as a word processor. The setfor command, which is loaded by this command line, allows older programs that were created to run in earlier versions of DOS to run properly within the newest version of DOS. If all your application programs are pretty up to date, this line won't be needed. It can help, however, if you are still running applications that were developed before DOS 5.0. If you get an error message from a program that says it can't run under this version of DOS, then you can add the setver line for that specific program to your Configsys file. The last line in this Configsys file would normally load a device driver for a fax. However, it has been turned into a simple remark since it has the letters REM in front of it. REM is a holdover from old programming language. Basically, it renders that line in your configsys inactive. Removing the REM will make the line and its command active again. The remaining lines in Suzanne's configsys file set default values for various system parameters. The parameter that's set is given in the name of the command, which takes the form command equals value. We have several of those settings in our configsys file, Suzanne. Let's take a look. The next command sets the number of memory buffers within DOS. Buffers are reserved portions of memory used to store information being transferred to and from your system's CPU and its drives. It doesn't matter if it is a hard drive, floppy drive, or compact disk. The number of buffers can be from 1 to 99. You can increase or decrease this number by using DOS shell to edit your configsys file. Increasing the number of buffers can increase the disk access for a certain program, such as a database. However, the more buffers you ask DOS to set aside takes up memory, which in turn decreases the amount of memory available to other programs. This can slow down the overall speed of your system and its program for the sake of improving the speed of a single program. The Files command sets the maximum number of files that can be opened within memory at one time. When working within a word processing program, for example, you may have a number of documents or files open at once. Within these files, you may have objects like a company logo, which itself can be a file. If the file setting is set for 20, you can have only 20 files open at any given time, no matter how many programs are running. 30 is a minimum for most database programs. The trade-off with the files is similar to that of buffers. Setting them to a higher setting reserves more memory, which is then unavailable for other programs to use. But a lower setting may reduce performance of some programs or cause them to fail. The software documentation should tell you what a program's minimum requirements are. Some programs automatically edit your configsys file during their installation process to change the file's setting. These programs will usually ask you for permission to make the change, or at least advise you that it is needed. Stacks reserves memory for information needed by the CPU about recent hardware activities. The numbers 9 and 256 refer to frames and their size in bytes. This is the recommended minimum setting for running Windows. If you don't have problems, you should probably leave this setting alone. However, if you get the error message internal stack overflow, you will need to increase the number of stacks. The first number can be increased up to 64. The last drive parameter tells the system how many drives may be used. A and B are usually floppy drives, and C is usually the hard drive, which may be partitioned into additional virtual drives called D, E, etc. A networked system may have many drives. If you add a drive, either physical or virtual, you must be sure the last drive setting in the configsys is a large enough letter to include all drives. Yet each new drive letter takes a little bit of memory, so don't use more than needed. The Fcbs command is an older DOS command that many of you may still have in your configsys, especially if you have continually upgraded DOS in an older machine. Fcbs stands for File Control Blocks. Most new applications don't require this command. However, many older applications do. They work in similar fashion to the Files command. One further parameter that may be important for optimal system performance is the shell. This tells DOS where to look for the command com file, so the path should be a complete listing of drive, directory, and file name. This command has two important switches. The /p switch tells DOS that this is a permanent copy of command com that can't be unloaded. For example, when you shell out from Windows to DOS, a second copy of the command com file is loaded into memory, and then unloaded when you exit back to Windows. The second switch is /e, which tells how many bytes to reserve for the DOS environment, which we set for the autoexecbat file. The DOS default is 160, but if you have many variables or if they are very complex, it is possible for DOS to run out of environment space. When that happens, an error message out of environment space will appear, and you need to use this switch to increase the memory allocation for environment. Start with /E:256 and reboot the computer to test. Continue to increase the amount by 16 and reboot until the error message disappears. If you have not seen this error message, there is no reason to change this setting since it will just take more memory for nothing. Other configuration commands can be used in the configsys file. We won't try to list them all here. Just remember that the general task of Fcbs commands is to set system defaults and load device drivers, and to reserve memory for those items. If memory is scarce on your system, then it may be worth your while to experiment with changes to this file. Or you can use Mem Maker to optimize the settings. We'll look at this option later in this lesson. Suzanne, after the Fcbs file does its job, the DOS boot up process goes looking for a special kind of batch file called AutoExecBat. You'll recall from earlier lessons that batch files simply store commands so they can be executed by the batch file, rather than rekeying each command whenever you want to use it. We can use batch files whenever we expect to use a sequence of commands on a regular basis. The commands within the AutoExecBat file are those we want to run every time the computer starts up. The commands you want in this file should set the way DOS appears on your screen and, to an extent, the way it operates. Before we look at the commands within Suzanne's AutoExecBat file, let's see what type of environment information was set for us by this file at startup. We can look at the current environment information, Suzanne, by typing set at the prompt. Each of these lines is an environment variable. The name of the variable appears first, and the setting follows the equal sign. So we can see 4 variables here: ComSpec, Path, Temp, and Prompt. ComSpec was set in the Fcbs file by the shell line, telling DOS where to put the command com file. The size of that memory space can be controlled by the /E switch on the shell command line, as we saw a moment ago. But what goes into the memory banks is determined by the AutoExecBat file or by direct keyboard input.
Professor, I'm getting confused. How are the AutoExecBat settings different from the ones in the Fcbs file?
The Fcbs file sets device drivers and allocates memory, basically telling DOS where to store and distribute information. The AutoExecBat file tells DOS how to set up your working environment, from customizing DOS commands to executing commands and starting programs you want running every time you start your computer. Now let's take a look at our AutoExecBat file. Everyone type the word type, followed by a space, and then the file name, autoexec.bat. Then press your Enter key. 2 kinds of commands are usually found in the AutoExecBat file: commands that set the working environment, and commands to load batch files and/or other programs. Once again, viewers, your AutoExecBat file will probably be different than ours, but don't worry. You'll soon understand the commands and what they do, so you can decide if you want to make any changes to your file. We just used the set command to take a look at the environment variables, so you might guess that the lines in our AutoExecBat file that include the word set also relate to those settings. Let's look at those first and see what kind of environment we're working with. The set temp line tells DOS the location of temporary files. All programs, including DOS, have files that open and close in the background during everyday computer operation. These are files you don't see and are important only for applications to perform. Normally, the temporary files are erased from the temp file when the application is closed. If for some reason your system shuts down before you save the file or close the application, these files can be automatically saved in the temp directory. When this happens, the temp directory may be left with a collection of these unneeded files. If they're kept in a separate directory, it's easy to find and erase them later to save disk space. Suzanne's set temp line stores temporary files into a temp directory called temp. Viewers, your file may be set to another directory such as DOS or Windows. If so, you may want to change that so this file is in the root directory. That way all your programs, including DOS, can find the temp directory. Of course, you must have a temp subdirectory available on your disk if you want to change the setting. How would you check that, Suzanne?
Well, Professor, I guess I'd do a dir listing, then look for a directory called temp.
Very good, Suzanne. You may have to hit your spacebar several times. It just depends upon how many files and directories there are on your system. There's your temp directory, Suzanne. Viewers, if you don't have a temp directory in your root directory, you should create one. Remember how to do that, Suzanne?
Oh, that's easy, Professor. Type MD, a space, the directory name temp, then press Enter.
Excellent. Viewers, did you follow Suzanne? If the directory already existed, you'll get this message. No harm done. But if you didn't have one, now you do. And with a temp directory, you can now set the temp command to place temporary files into this directory. Everyone type the word type followed by a space and the file name autoexecbat. When you finish, press your enter key. Another set command that you can use in your autoexecbat file is the dir cmd, or directory command, which sorts your directory listings. We've suggested this command in earlier lessons, so this is just a reminder. /o:\gn lists the subdirectories first, then the files in alphabetical order. /p causes the display to appear one screen full at a time. Not all the environment settings use the set command. Path and prompt settings do not use set, nor do they use the equal sign. Our prompt $P $G setting is a standard setting used by most computers. It tells DOS to display the current directory, that's the $P, and follow that directory with a space and a greater than sign. Right now we are in the root directory, so our prompt says C:. Suzanne CD to the Windows directory. See how the prompt changes to display our new directory? The $G creates a space and a greater than sign. Visually, it helps us separate the directory listing from the commands. Suzanne CD / to get back to DOS. This line displays the directory path for Suzanne's system. Your path will vary in length according to the number of programs on the system. The path statement can be very lengthy, since it is a search path for all the directories where DOS should look to find the command file when the command is issued. DOS recognizes a command file by its COM, EXE, or BAT extension. Without any directories listed in the path statement, DOS will only look at command COM and the currently active directory. You would have to type a full path listing anytime you gave a command in order for DOS to find and execute the command. Obviously, the path statement can be a tremendous time saver. Many programs will automatically modify the path statement in your autoexecbat file when they are installed on your computer. The names of the directories are separated by a semicolon. There should be no spaces in the list of directories. A word of caution here. The longer the list in the path statement, the longer DOS takes to search for an executable file. In addition to the environment settings, your autoexecbat file can be used to call other programs or batch files. Some of these programs are called Terminate and Stay Resident, or TSRs. The TSRs are utility programs that load into memory and remain working in the background until you turn off your computer. This is useful for a variety of DOS utility programs including Smart Drive, vSafe, Undelete, and DOSKey. Suzanne has 3 TSR programs in her autoexecbat file. This command line in the autoexecbat file automatically loads DOSKey whenever the computer is started. We've seen in earlier lessons and in today's lesson how DOSKey can speed up your work by recording and recalling DOS commands. This line loads the Undelete tracking program. You'll remember it from my Level 2 lesson. It makes it possible to restore files previously deleted by the delete command. Here we see a similar set of instructions to load the Smart Drive utility. Smart Drive is a disk caching utility that speeds up the transfer of information between memory and disk. It stores memory information in a buffer called a cache, so programs can look first to the cache to get data quickly rather than reading the slower disk. Smart Drive also stores information that's ready to be written to the disk and writes it in a batch. The caching is done in extended memory, so it doesn't use much conventional memory. Smart Drive caches CD-ROM drives as well as floppy disk drives. If your system has a CD-ROM drive, you might see this mscdex command in your autoexecbat file. This command line should come before the line that loads Smart Drive.
Professor, this Smart Drive seems like a pretty useful program. Is there any way I can check if it's working on my computer?
Yes, Suzanne, you can check which drive or if any drives are being cached by Smart Drive. Type smart drv /s, then press enter. This is a list of all the drives that are being cached. A and B are your floppy drives. C and D are Suzanne's hard drive partitions. If you have Smart Drive running, you can reduce the buffer setting in your Fcbs. Smart Drive takes over some of the work that is being done by buffers. The display tells whether each disk has a read cache, a write cache, and if it has buffering. A cache is a high-speed buffer area. The read cache temporarily stores information being read from your hard or floppy drive. The write cache stores information that needs to be written to disk. Using Smart Drive to create cache areas is a good way to increase the speed of your system. However, you should be aware that you will lose data stored in the write cache area if you have a power failure. The /S switch on the Smart Drive command asks for the hit rate, which we see displayed above the status table. This hit and miss score gives you some idea of how much Smart Drive improves your disk efficiency. If you have more cache hits than misses, your system is efficiently using the cache area to quickly transfer information between your drives and memory. Suzanne has over 1 meg of cache area to use during system operations. We are also given the amount of cache area available to us while working within Windows. Suzanne, let's go back to our AutoExec bat file so we can look at the other elements that make up this important file. Type in type, a space, and the file name AutoExec bat. Then press your Enter key. The echo off statement simply tells DOS not to display the text and commands within a batch file while it is running. Whatever message appears within the Go To Start and Start comments will be displayed when you first boot up your computer. You could change this line to read anything you want. Perhaps you could write, "Remember, this isn't brain surgery." The last line may not look like much, but it has an important job. It is an executable. It calls into memory the batch file that launches Windows. You can change this line to launch any program on your system.
Professor, I think I understand the config.sys and AutoExec bat files a little better now. So how can I make changes if I think they're needed?
That's why we spent all this time looking at all these commands. Now it's time to try some changes. Remember, you have working versions of these files on your backup disk, so the safety net is still in place. One further caution for our viewers. If you're not working on your own machine, it's very bad karma to mess with someone else's configuration files. So just watch this section. Now, Suzanne, to change or edit these files, we can use the DOS editor. Type edit, space, autoexec.bat, and press Enter. The edit command opens the DOS editor program with our AutoExec bat file on the screen ready for changes. Notice how each line begins at the left margin. You should not use any indents on a command line. Each line must end with a carriage return. That's the Enter key. Although DOS can interpret upper and lower case, it's a little quicker with capitals, so make sure your caps lock key is turned on. Each command has a line to itself, so you must start a new line when you want to add a command. Suzanne, let's just add a line at the bottom of the file. Use the down arrow key to move the cursor down to the end of the last line. Now press Return to make a new line and type "This is a new line." Obviously, this is not a DOS command, but you can see how the editor works. If you want to remove a command line, you can simply delete it, or you can leave it in the file and add the letters REM at the beginning of the line. Do that, Suzanne. Just use the arrow key to move the cursor to the beginning of the new line and type REM and a space. This indicates a remark, and DOS will simply ignore that line. This is a useful way to test how the system works without a given command line. If you decide the line is necessary, you only need to edit out the REM rather than typing the whole line again. To move a line, you can select the whole line and then copy and paste it. Shall we test that, Suzanne? Move your cursor to the beginning of this line. Now hold the Shift key while you arrow across the line to mark it. That's right. It shows a highlight for what's marked. Now hold down the Alt key and press E to open the Edit menu. Here's Cut, Copy, Paste, and Delete commands. We want to cut, which is the highlighted command, so just press the Enter key to execute that command. The line has disappeared from the screen, but it's being held in a little memory buffer until we show DOS where to paste it. Move the cursor to the top of the file, Suzanne, and select the Edit menu again. Alt-E, and select P for Paste. There's the new line. We don't want more than one command on a command line, so we'll need to separate the two, even if one of them isn't exactly a command. Move the cursor to the beginning of the echo off line, then press your Enter key. Always remember that when editing these files, to keep one command per line. Of course, you can guess how to remove it completely now, can't you? Select the line again, then use the Delete key to clear it. Then use the Delete key again to clear the blank line. Viewers, if you made a temp directory earlier in the lesson, you should edit the set temp line so the temporary files are stored in that directory. First, find the line that says set temp and an equal sign. If your line ends with anything other than C:\temp, you need to change it. Don't make any changes if you did not create a temp directory. Suzanne, your file is fine, but you can show our viewers how to edit anyway. Move your cursor to the first letter of the directory on this line. Hold down the Shift key and press the right arrow to highlight the temp directory. Now retype TEMP. Your typing will replace the highlighted letters. That's all there is to it. Viewers, you'll have to decide for yourself what changes to make to your configsys and autoexecbat files, but you can see that it's a simple editing process. When you've made any changes, you must save the file. Press the Alt and F keys. While we're working on the screen, everything is in memory. The Save command under the File menu writes your changes to the disk, so they're available to the computer for the next startup. You haven't made any changes to your file, so exit out of the editor. Press X, Suzanne, and answer No at the next prompt. After you've changed either of the configuration files, you must turn off the computer and restart it so the new instructions can be loaded. If the machine fails to start correctly, or if you get error messages, you'll have to look for the problem command. You might want to use the step-through process we saw at the beginning of this lesson to troubleshoot each file a line at a time. Remember, you just press the F8 key when you see the message Loading MS-DOS. If DOS detects an error when it processes either configuration file, you will be given an error message indicating which command line is causing the problem. It won't provide you with a quick fix solution, but it should steer you in the right direction. If you cannot find the problem, you can always use your emergency boot disk to reboot the computer. Once your system is up, copy the working versions of the configuration files from your floppy disk over the versions in your root directory. Once done, reboot your computer. Viewers, if you haven't done anything to your autoexecbat file, don't do anything. Just exit out of the editor. When you set up your configsys and autoexecbat files to work exactly the way you want, you can also use some other DOS utilities to optimize the performance of your computer. The first thing we will do is run our good friend Mem Maker. It optimizes your system's memory by moving device drivers and memory resident programs to upper memory. To run Mem Maker, you must have a 386 or higher CPU in your system. We'll also look at ScanDisk and Defrag, which will clean up and improve the performance of the hard disk. When we're finished, you'll need a seatbelt to operate your computer. It'll be so fast. Viewers, we cannot predict what changes Mem Maker will make to your files or whether it will improve the operation of your computer, but it's a useful utility to try out. Mem Maker may make changes to both configuration files, configsys and autoexecbat in order to optimize the use of memory. Suzanne, type Mem Maker and press Enter. When the Mem Maker title screen appears on screen, press Enter to continue. The next screen allows us to choose between an Express or Custom Mem Maker run. We want an Express run, and since it is already selected for us, press your Enter key. The following screen asks you if you will be using expanded memory. Unless you are absolutely sure you will never use software that uses expanded memory, answer No by pressing your Enter key. From here, remove all disks from your floppy drives, then read the screens that appear before you. Answer accordingly. There won't be anything that you can't handle. The program will check your configuration and then rewrite your configuration files. Mem Maker may reboot your computer twice to see if everything works correctly. If your autoexecbat file starts Windows or some other program, you may need to exit out of it to allow Mem Maker to continue. When Mem Maker is finished, it will ask you if your system is running okay. If it isn't, select No by pressing the spacebar key to select No, then press your Enter key. This will restore your system settings before you ran Mem Maker. If it is running smoothly, press your Enter key. The next screen gives us a readout of how much conventional and upper memory has been freed up by Mem Maker. Mem Maker optimized Suzanne's memory by almost 14K within the conventional memory area. And it freed the same amount of memory in her upper memory area. This will allow other programs to use this free memory during everyday computing. Since it makes changes to your configuration files, Mem Maker leaves copies of both AutoExecBat and Fcbs in the DOS directory with .umb extensions. Remember that if the changes do not work, you can recover those files, or you can restore the backup files from your emergency floppy disk. Suzanne, press your Enter key to exit out of this screen and Mem Maker. Now, let's see what changes, if any, Mem Maker made to our Fcbs file. Suzanne, type Fcbs and press Enter. We have two changes here. The first change occurred in the buffers command line. Before Mem Maker, we had only 20 buffers, nothing less. Now we have a comma and a 0 after it. The second number represents secondary buffers. Secondary buffers worked like primary buffers. The second change was made in the setver device driver line. Mem Maker added the /L:1,12048 to this line. It tells DOS to load this device driver into a specific place, which this number represents every time you boot up your computer. When Mem Maker was looking at your system, it looked at the best way to arrange the device drivers within memory. It concluded that this was the best place for the setver driver within memory. Now, let's look at the AutoExecBat file. Suzanne, type AutoExecBat. This file has been changed too. Within this file, 3 command lines have been changed. Each has been given a specific place in memory where it will load into at startup. The LH you see in front of the memory position numbers stand for Load High. The command loads utility programs such as DOSKey and Undelete into upper memory, which once again makes more conventional memory available to applications other than DOS. Since both these configuration files have been changed and more memory is freed up by these changes, you should copy the new files onto your emergency backup disk. Use the same copy commands you used earlier in this lesson to copy from the C drive to your floppy drive. We've optimized our memory. Now let's take a look at optimizing our hard drive. The first hard drive optimization tool we will look at is ScanDisk. ScanDisk is a new full-screen utility program that detects, diagnoses, and repairs disk errors on uncompressed drives and double-space compressed drives. Suzanne, type ScanDisk/check only, that's one word, and press Enter. The check only switch tells you that we are only checking, not making changes. The program starts and checks for bad sectors, boot sector errors, and cross-linked files. ScanDisk also checks for directory tree structural errors, double-space drives, and file allocation table errors. Our ScanDisk is done and shows that we have no errors on our disk. Remember, we were just checking this time. Viewers using this feature will let you know if your hard drive has problems. ScanDisk offers several disk repair options, or you could use other disk recovery utility programs. That's a little beyond the scope of this lesson, but you can use the DOS help command to investigate the ScanDisk options or check the documentation for other utilities. In any case, if ScanDisk shows errors on your drive, you should back up your data before attempting any kind of fix. So this is a good time to learn about the new Msbackup program that makes backups easy. Before we do that, we need to press the X key to exit out of this utility program. It is essential to have backups of your work. You should make backup copies of your application programs before you ever load them onto the computer. But you also need to back up your work files. A daily, weekly, or at least monthly schedule is recommended, depending on how much work you do and how critical the data is. Type Msbackup at the DOS prompt. One of two things will happen. You will see the screen if Msbackup has been used on your system. Or you will see this screen. If this screen appears on your system, you will need to configure Msbackup for your system. And to do that, you will need 2 blank floppy disks and about 5 minutes. Answer the screen questions and DOS will walk you through the procedure. The Msbackup configuration program will ask you to insert the floppy disks so it can transfer files to them. It will then compare these copied files to the original on the hard drive in order to check compatibility. Once the configuration is finished, you will be given the first screen we saw where everyone can start at a complete or partial backup of your hard drive and its files. When you select the backup command, you will be given a screen where you can tell DOS which drives and/or directories you want to back up, and to what floppy drive to use in the backup procedure. The number of floppy disks needed will depend upon how many files you are backing up. Be prepared to have a lot of disks on hand if you back up an entire drive. When you finish your backup, pull down the File menu and select Exit. The last utility I want to show you is the Disk Defragmentation utility, Defrag. This utility program does a great job of putting your files in order on your hard drive or floppy disk. This makes it easier to find and use your files. Viewers, a word of caution here. There is a chance that you could lose some data while using Defrag since it moves data around your disk during its reorganization process. Although the chance of this happening is small, you should back up the files on whatever disk you are going to use Defrag on. The drive might or might not need it, but the program will tell you. If you haven't backed up your files, just watch this section as Suzanne goes through the steps. Suzanne type Defrag and press Enter. The first screen asks you to choose the drive to be optimized and offers a list of the disk drives on your system. You can use Defrag on either hard or floppy drives. We'll optimize the hard drive, C, Suzanne. It is already highlighted on your screen, so press the Enter key to proceed. Now we see a map of this drive, which shows how information is distributed among the available slots. The legend at the lower right corner of the screen interprets the symbols on the map, so you can see which spaces are used and unused, which are bad, and which are unmovable. Suzanne's C drive is 17% fragmented. Defrag recommends a full optimization. This method will unfragment data and application files. The two buttons at the bottom of the recommendation window allow us to accept the recommendation by selecting Optimize, or to change the configuration to your own choice by selecting Configure. Suzanne press Enter to select Optimize. And then just sit back and watch the show. Defrag will move the file clusters around to group together all the pieces of a file. The R and W codes show which pieces are being read and where they have been written to complete the consolidation. The status bar at the lower right corner shows Defrag's process in form of a percentage. You can also watch the cluster count. Defrag is pretty quick, but it may take up to 30 minutes to complete. The duration of time depends on how fragmented the disk is. If for some reason you need to stop Defrag, you can press your Escape key. When the process is complete, another dialog box reports the result and will allow you to optimize another disk, change the configuration, or to close the Defrag program. I think we're finished here, Suzanne, so select the Exit option. We now know how the Fcbs and AutoExec bat files affect your system's performance. We also learned how to edit those files. We saw how Mem Maker affects the commands within those configuration files too. We then saw how to use ScanDisk, Msbackup, and Defrag to increase the efficiency of our hard drives. That's quite a lot to learn in one lesson. Thank you for your help, Suzanne.